Now we're going to sketch this curve of these two parametric equations, and we're also going to write these parametric equations in rectangular form. That means in terms of the x's and y's. So what we're going to do first is just, again, do a table. For each of these curves that we graph, we have to just essentially get a table. And with this graph, I'm going to actually start with some negative values here. So I'm going to start with negative 10, then negative 9, negative 8, negative 7, negative 6, negative 5. And I'm going to go all the way to the positives, which means I'm going to need another table to set up. So now we're going to just start plugging in the values like negative 10. And again, I'm going to approximate just for the sake of graphing these. So essentially I'm going to say, okay, so if I have my x, let's say I'm doing negative 10. So it's going to be e to the negative 10. And then, like I said, I'm going to have to approximate that. So for this first pair, e to the negative 10 is 0.00045. So e to the negative 20 is going to be a lot smaller than that, almost 0. So this really approximates to 1 for the y value. And the x is almost 0. So those are some pretty small numbers for the e to the negative 10 and e to the negative 20. And think about what that is. It's really 1 over e to the 10th. So yes, it should be a small number. That's what the negative exponent does, flips it to the bottom. So anyways, what this shows me is my boxes are way too small for those digits. So I'm going to have to get bigger tables. So there's my first point. So I'm just going to continue this process now and finish the table. So there's all the values. We didn't need quite that many. I'm definitely not going to graph all these. If you look at the y values, like here, they jump way up to 55, and my graph only goes up to 15 there. So I'm probably only going to do a handful of these values. I did want to also show you here that in the beginning here, a lot of these are almost 0. And on the other y's are 1s. So they're all very close to that. So if I was going to graph that first point then, that means it would be 0, 1. So 0, 1 would be there. And the other one next to it is almost 0 and 1. So it's just going to be slightly to the right of it. So a little more than 0, and it's about 1. So I could just keep doing those points, and they're almost just 1. But actually, they're just a little bit more if you think about it because of that first one I did. But anyways, they're all very close together. So that with that 1 over e scenario that we had early, e to the negative, or I should say e to the 10 on the bottom there. If I put more negative values in, this is just going to get closer and closer to 0. So that's why we see that x just going to 0. So anyways, let's graph the rest of these points, at least what we can. Now another good point that we could graph here, now these are still all about 0 and 1, close enough. Our next value here would be here. That value would be 1, 2. So we go over 1 and then up 2. That would be a good value. And then maybe the next one here, that will probably be a good one too. Oops. So that next one would be here where t is 2. And where t is 3, that kind of gets off my graph there. So I'm just going to draw this now. So there's our graph. It sort of looks like a parabola. Now, like I said before, we could have used a lot less values there. We didn't need all these. But I definitely wanted to show you how it's actually going to go to 0 on the x's and 1s on the y's. So it's like there's just a ton of little points in here that would end up with, if we just kept going and we just get closer and closer to that 0, 1. And that's what I think is actually a little bit strange here, because when we look at this, at least when I look at this, I see this as a variable here, and this is that variable squared, because really e to the 2t is equal to e to the t squared. So really what we're seeing here is this is a variable here, and that's the variable squared. And that's why it kind of looks a lot like a parabola, at least on the one side there. So that's kind of an interesting thing. Now let's say we converted this to rectangular form, because that's what I want us to do now. So a really nice thing is we already have x equal to et, and my y is really equal to, and just what I said a minute ago, e to the t squared, because that's what that means, plus 1. So now, since x is equal to et, that means my y is going to equal x squared plus 1. So that's really the equation that I see here. And that's what it'd be in rectangular form. So that's what's kind of nice, and we're really just seeing half of that parabola. So it does limit the other side of that parabola by using those parametrics, which I think is strange. So the parameters for this would be from zero to infinity, or I could say, and this ways to think of it, this would be interval notation here. So that's what we're actually looking at. So some of these problems ask for the domain and range too. So here I can see that the domain, and I'll write that here, that's what I found here was the domain. The range would actually be from 1 and it goes all the way up. And the range is my y values, that's why I say I'm going up. And that would be from 1 to infinity. And I use parentheses with infinity because infinity is just an idea. It's something we never really attain. It's larger than any number we can think of. So there we go.